friends, in this video we are going to discuss about special questions in DC machine. Let's see first one. Is the motor rotates in same direction or opposite direction of generator? I said you already, motor and generator rotates in opposite direction. For that, take a small clarity. See, for example, this is my generator. Are you okay? Generator given by the prime mover torque. This is my prime mover torque. When the prime mover torque given to the generator, the rotor will rotate in this direction, for example. In every generator, what happens, sir? In every generator, motor action will take place, which produces the torque. Are you getting or not? Which produces the torque, which is in opposite direction to the prime mover torque. Yes or no? So this is my prime mover torque. Then electromagnetic torque will produces, which is in opposite direction to the prime mover torque. So in generator, the electromagnetic torque and the speeds are reversed to each other. This is the concept in generator. For example, if you take the motor, for example, this is my motor. We have to give electrical supply. When electrical supply given to the motor, it produces the torque. For example, the torque produced in this direction, for example, this is my electromagnetic torque, because in motor action, electromagnetic torque will produce us. Then, generally this is a motor, that's why when the torque produces, as usually, speed also produces, that rotates in the same direction of electromagnetic torque, because the speed is only due to this torque, but here the speed is due to this torque, and here the electromagnetic torque is opposite direction to the prime mover torque. This is simply the motor and generator action. See here the torque, nothing but electromagnetic torque, and the speeds are in same direction. This is important. This is in same direction, but in generator, both are in opposite, reverse direction to each other. This is simply the first concept, how they will rotate. Is it okay, clear? Right? Okay, right, sir. Next, second concept. Second concept. In DC shunt motor, if supply reversed, then what happened? If supply reversed, then what happened, sir? Could you tell me what happened, sir? For example, this is my DC shunt motor. Let's see here. This is the supply. Of course, this is my armature. This is the current. Of course, armature current as well as the shunt field current. Okay. Now, what happens are my supply terminals are reversed. Like this. My supply terminals are reversed. Now, this is minus, this is plus. Before, actually, what are the plus, what are the minus? Actually, plus, minus. But now, minus, plus, supply reversed. Actually, when this is plus, current is flowing like this. But when this is plus, the current flows like this. This is. Then what happened? See here, we know the torque. This is a motor. The torque directly proportional to flux and armature current. If flux is reversed, torque reversed, then rotor rotates in reverse direction. If armature current reversed, then torque reversed, then rotor rotates in reverse direction. See here, what happened here? When the armature current is flowing like this, nothing but the armature current is reversed. And here, the field current also flowing in this direction. Actually, this is the direction. But when supply reversed, the current flowing in this direction. So here, flux also reversed. If both are reversed, minus into minus plus, hence no change in direction. No change in direction. Sir, is the flux increased or decreased? There is no increment in flux, there is no decrement in flux. If flux decreased, speed increase. If flux increased, speed decrease. But here, no change in direction and no change in speed. This is, sir, if the supply reversed in DC shunt motor, what happened? Nothing will happen. Even though it is plus minus or minus plus, nothing will happen. There is no change in direction and speed. Sir, this is for DC shunt motor. What about for DC series motor? Can you tell me what about for DC series motor? For example, this is my DC series motor. Is like this. Are you okay? How the current actually the current should be like this. But when the supply terminals are reversed, nothing but this is minus and this is plus, then the current flows in this direction. Nothing but here armature current reversed as well as flux reversed. If both reversed, there is no change in direction and speed. So, what is the conclusion, sir, from this? Can you tell me what is the conclusion? In DC machine, in DC motor, whatever, shunt motor or series motor or compound motor, whatever it may be, in DC motor, if supply reversed, what happens, sir? If supply reversed, there is no change in speed and direction. There is no change. Even though supply reversed, there is no problem at all. This is simply about DC shunt motor, series motor, compound motor. For all the motor, if supply voltage reversed, what happened? Nothing will happen. The first question is this one and the second question is this one. Are you clear up to now? Right, sir. In motor, if supply reversed, nothing will happen. Then my third question is, in generator, in DC shunt generator, if prime mover input reversed, what happened, sir? Prime mover input reversed, then what happened? This is my third question. Can you tell me what happened? Don't say nothing will happen. It will happen. Something will happen. So what is that? Let's see here. Let's see what happened. See that? In third concept, we are going to see the question. I am removing this. First concept completed. Second concept for motor. And third concept for generator. I am taking DC shunt generator. In third concept, first question. In DC shunt generator, the third concept I am taking here, generator. For example, how the generator, DC shunt generator, like this. This is my DC shunt generator, which produces the armature current and which produces the generated EMF EG and the armature current. This is line current, and of course this is ISH, and of course residual magnetism also in this direction. The ISH will additive to the residual magnetism, we already know that. So the third concept, in DC shunt generator, first question, if prime mover input reversed, then what happened? Actually, the prime mover input to the machine is like this, and this is rotating in this direction, nothing but clockwise direction. I am rotating the rotor by using prime mover in clockwise direction actually. But what I said, if the prime mover input of the DC shunt generator reversed. Now what I am doing here, now I am going to reverse the prime mover input, then the rotor also rotates in this direction, then what happens, sir? If the prime mover input reversed, then this is changed as A. How it will change? Let's see. This is the field winding and this is the supply, and here I changed my prime mover in counterclockwise direction Actually, this is in generally rotates in clockwise direction, but I changed my prime mover input. When the prime mover input change, then automatically the generated EMF terminals change. When this will change, and this is also change, the first change. When the prime mover input reversed, then automatically easy terminals reversed. You should remember this point. When the EG terminals reversed, then what is the flow of current? The flow of current is in this direction, like this, not from here. The current will flows like this, and current will flows like this. This is my ISH, and this is my IL. But what is the direction of residual magnetism? The residual magnetism direction is like this. See here, what the ISH do? Here, ISH cancels the residual magnetism. Is yes or no? What happens are here? Here ISH go and cancels the residual magnetism. If it is cancelled, if there is no residual magnetism in separately excited machines, then what is generated EMF, sir? The generated EMF is 0. This is the case. If the prime mover input reversed simply, then there is a no generated EMF, there is no buildup of EMF, is the first question. Next, what is the second question in this concept? If prime mover input reversed and what happens, sir? Field winding reversed. Field winding reversed. Then what happened? See, actually this is the circuit, but now the prime mover input reversed and field winding terminals also reversed. Then what happened? Let's see here. Actually this is the supply, and this is my armature, is like this. Here when the armature terminals reversed, then automatically what happened? What I said you, this easy terminals reversed because the prime mover torque in counterclockwise. That's why this is also reversed, minus plus. And field winding terminals reversed, I said you that nothing but when the field winding terminals reversed, nothing but this is connected here and this is connected here. And what is my residual magnetism direction? Actually residual magnetism in downwards. Let's see here what happened. Here this is the line current and this is the shunt field current. How the shunt field current? Let's see. Actually the current is flowing like this, like this, like this. This is the shunt field current. Tell me, is the ISH additive to the residual magnetism or subtractive to the opposite to the residual magnetism? This ISH strengthen the residual magnetism. It is in additive to the residual magnetism. There is no cancellation of residual magnetism. Then what happened? It produces the EZ, but in which direction? With the negative polarity. This is what our answer. When the prime mover input and field winding both are reversed, then negative polarity EMF will generated. This is what the third question. Next, what is A, B? Next one, C. Now what I am going to change? Prime mover input change, field winding reversed, and residual magnetism also reversed. Then what happened? This is the third case. Tell me, sir, what happened? See what happened. For example, this is the load, and here the armature winding, and here the field winding. Actually residual magnetism in which direction? Downwards. Now the residual magnetism should be upwards, is the first one, and field winding also reversed. What happens are here? I changed the residual magnetism, I changed the field winding, and I have to change the prime mover input. when the prime mover input changes, the EB terminals changes. And when the residual magnetism also reversed, again the EG terminals reversed. Again EG terminals reversed. First is minus plus. When the prime mover input reversed, minus plus is like this. When the residual magnetism reversed, again reversed. Nothing but again plus minus only. This is simply what? The prime mover input, field winding and residual magnetism reversed. When actually this is the easy. When the prime mover input reversed, this is also reversed. Again when the residual magnetism reversed, again this is also reversed. So nothing but again came to the same position. Now tell me what happened. At this condition, the current IL is in this direction and the ISH in this direction. This is my ISH. Here also there is no cancellation of residual magnetism. So EZ produces with negative polarity or same polarity. EZ produces with the same polarity. This is the question C in third concept. Question 1 in third concept. Question 2 in third concept. And question 3 in third concept. Now the question 4 in third concept is your work. You have to do this. I won't tell you. So what is that? Can you tell me? If the prime mover input reversed and the residual magnetism reversed, when these two are reversed, what is the answer? Option A, there is no EMF induced. Option B, EMF induced with negative polarity. Option C, EMF induced with the same polarity. Option D, none of the above. Machine damages. So, tell me, what is the correct answer? You have to done for this. You have to do it. Are you clear? Up to now, this is the third concept in generator. First concept is what is the direction of motor and generator. Second concept is if the supply terminals reversed in the motors. And the third concept is if the prime mover reversed in the generators. And actually I explained with the DC shunt generator, but this is the answers for any generator. Not only DC shunt, for DC series and compound, whatever the DC generator, for all the generators, the questions are same and the answers are same. Are you okay? See here, the next concept, fourth concept. What is the fourth concept? See here. A DC shunt generator delivering rated power to the bus bar. What is that? Here a DC shunt generator using which delivering rated power to the bus bar. Suddenly, if suddenly prime mover disconnected, then what happened? What happens are here? A DC shunt generator delivering rated power to the bus bar. If suddenly prime mover disconnected, then what happens? Very simple. See here. For example, this is my DC shunt generator, which is easy. This is the load or supply. Like this. Here the armature current. Here the ISH. Of course this is easy. And it delivering current to the bus bar is like this. Actually this is connected to a prime mover. Now this is connected to a prime mover is like this. We are giving the prime mover input to the generator. It delivering current and it delivering power to the bus bar. This is going on actually. Suddenly what happened? At one particular time, if suddenly prime mover disconnected, here prime mover disconnected, then what happened, sir? When the prime mover disconnected, then automatically the motor, actually this is a generator, but when the prime mover disconnected, it will absorb the current. Nothing but the IL direction is in this direction and IA direction in this direction, the machine absorbs the power from the bus bar. When it is absorbing nothing but the DC shunt generator is converted as a DC shunt motor. When the prime mode is disconnected, the generator act as a motor. Now this is my DC shunt motor. Okay sir, DC shunt motor, good. Actually the prime mode direction is this direction and speed also actually in this direction, but suddenly the prime mover is disconnected. When the prime mover is disconnected, the current direction is reversed. Due to this reverse current direction, the generator acts as a DC shunt motor. I know. Is the motor rotates in same direction or opposite direction? Is the motor rotates with the same speed or increased speed or reduced speed? These are the questions. Tell me, what happened? Actually, in the same, whatever it is, generator or motor, the ISH direction is same. When the ISH direction is same, the flux direction is same. The flux in the same direction. And the magnitude of flux also same. When the magnitude of flux also same, nothing but the flux is constant. If the flux is constant, the speed also same, which rotates with the same speed. There is no increment in speed. There is no decrement in speed. Okay, sir. Speed clear. The DC shunt generator acts as a DC shunt motor with same speed. In same direction or opposite direction? Let's see here. Generally, when it is act as a motor, it will develop the electromagnetic torque. The electromagnetic torque produced in which direction? The electromagnetic torque should produce in opposite direction to the prime mover input. Actually, this is prime mover input. Opposite direction to the prime mover input is nothing but the electromagnetic torque, because this is a motor. Let's see actually what is the torque here. Actually, it is produced like this in motor, but the torque directly proportional to phi into Ia. What happened here? The flux is reversed or positive. The flux in same direction, that's why flux is same. But what about armature current? Armature current reversed and the electromagnetic torque also reversed. Nothing but actually it should be produced in this direction. But due to reversal, here the electromagnetic torque also reversed because the armature current reversed. That's why this electromagnetic torque produced in reverse direction. Now, this is a motor. When the motor is there, then the electromagnetic torque and speed should be in the same direction. Here also both are in the same direction. That's why here the torque is reversed, but there is no change in direction. The direction of rotation is same. The direction of rotation is same. This is generally the concept when the prime mover is disconnected. When DC shunt generator delivering rated power to the bus bar, if suddenly the prime mover disconnected, then the machine acts as a DC shunt motor which rotates in same direction with the same speed. This is what the question and fourth concept, first question. Are you okay? Right? Next one. In this, the second question. In the same concept, the second question. This is very important, sir. Comparatively, in these special questions, the most important question now which I am writing. So let's see clearly. So, second question. A cumulative compound DC generator delivering rated power to the bus bar if suddenly prime mover disconnected What happened, sir? Prime mover disconnected. Then what happened? Here you have to remember, I said you only cumulative compound DC generator, but I am saying you a cumulative, a long shunt cumulative. A long shunt cumulative compound DC generator delivering rated power to the bus bar. If suddenly prime mover disconnected, then what happened? This is my question. Let's see what happened. First of all, take the cumulative compound. Long shunt cumulative compound DC generator. See, this is the bus bar. Here the series field winding in series to the armature winding. And here the long shunt. Like this. Actually, it will deliver the armature current. It will develop the ISE. Here the current IL to the bus bar. Here the current ISH. Actually, we are giving prime mover input in this direction, which is the prime motor, and the rotor also rotates in the same direction, which delivering power to the bus bar continuously. But what happened here suddenly? The prime mover disconnected. My prime mover is disconnected. When the prime mover disconnected, the line current direction is this one, and this direction is like this. ISC direction reversed, IA direction reversed, but there is no change in ISH direction. What happens here? ISE direction and IA direction both are reversed, but ISH direction same. There is no change in ISH direction. What is actually this generator? Actually this generator 5SH plus 5SE, because cumulative compound. Now this long shunt generator converted as a motor because it drawing the current from the bus bar. So the long shunt generator converted as a, is it long shunt motor or short shunt motor? Is a silly question, right? This is 100% long shunt motor only. The long shunt generator converted as a long shunt motor. Which type of generator is this? This is cumulative type of generator. Is the cumulative type generator converted as a cumulative type motor or differential type motor? Let's see what is phi in this case. In this case, there is no change in phi SH, hence the phi SH is same, nothing but take the positive only. Phi SH is the positive only. But here phi SC direction is same or reversed. Phi SC nothing but ISC. If the ISC direction reversed, nothing but the phi SC also negative in this case. Nothing but here actually it should be in this direction, upward. But now the current in down direction. That's why the phi SC is reversed. Nothing but in this case phi is equals to phi SH minus phi SC, because ISC direction reversed when it is act as a motor. So simply the cumulative generator converted as a differential motor. So two things are completed. The long shunt cumulative compound DC generator converted as a long shunt cumulative compound differential motor. Not cumulative compound, differential compound motor. What happens, sir? Long shunt cumulative compound generator converted as a long shunt differential compound motor. This is the answer. Of course, we know that, sir, generator act as a motor, long shunt only, but cumulative generator act as a differential motor. If differential generator is there, then the differential generator act as a cumulative motor. Differential to the cumulative, cumulative to the differential. We know that, sir. Is it rotates in same direction or opposite direction? If the same direction, increase the speed or reduce the speed? Like that they will ask you question. So tell me, is the same direction or opposite direction? To know that, we have to know the torque. Yes or no? So let's tell, actually this is motor. Actually in motor, the torque should be like this, electromagnetic torque. It should produce like this. But see here, the electromagnetic torque is directly proportional to phi Ia. Here, the flux is phi sh minus phi se, but here the flux is phi sh plus phi se. Now tell me, if this flux is positive, is this is the positive or negative? 100% positive only, because this is phi sh is always greater than phi se. We know that always the phi sh is greater than phi se. When this is correct, then this is 100% positive only. Hence the flux is positive. But what about armature current? Armature current is reversed. If the armature current is reversed, torque reversed. So actually it should be in this direction. But due to that operation, this is rotates in reverse direction. So this is a motor. In motor, tell me, in motor, the prime mover torque and the speed should be in same direction or opposite direction? Should be in opposite direction. Yes or no? Should be in opposite direction. That's why the rotor rotates in the opposite direction. The rotor rotates in the opposite direction. Be careful. Here, this is simply, now tell me, is the rotor rotates in same direction or opposite direction? Here, my rotor rotates in opposite direction. This is simply, actually speed in this direction. Now due to torque, when the torque is in this direction, then the speed should be in opposite direction, because in our motor, the torque and speeds are in opposite direction to each other. Yes or no? I said you or not? Right. So, in which direction? Tell me. Yeah, in motor, the prime mover torque and speed should be in same direction. That's why here, the direction of rotation is same. Leave it. So, direction completed. So, a long shunt cumulative generator act as a short shunt differential compound generator motor which rotates in the same direction with increased speed or reduced speed. Very simple. See here, when check here, this is positive but the flux is additive. Of course, this is also positive but the flux is subtractive. When the flux decreases, then automatically what happened? Speed increases, because the flux is inversely proportional to speed. Are you know? The flux is inversely proportional to speed. So what is the question here? The cumulative compound DC generator act as a long shunt differential compound DC motor which rotates in the same direction with increased speed. Okay? With increased speed. This is the question, fourth concept, second question. Right? Okay. Now, in the same question, what is that? A long shunt cumulative compound DC generator delivering rated power to the bus bar. If suddenly prime mover input disconnected, then what happened? And in the bracket they given that up to now phi sh greater than phi se, but now they given that phi sh is less than phi se. They given in the bracket. Then what happened? Can you tell me? Yeah, can you tell me? See here, the ISC direction. This is nothing will change as T is only ISC direction and IA direction reverse. So phi se is negative direction and there is no change in phi sh, is the same, and this is positive only. So the long shunt cumulative generator converted as a long shunt differential compound motor. Is it clear? Next, when comes to torque, see here, this is, even though the phi sh is less than phi se, even in this condition, the flux is positive only. But when came to here, here my phi sh is less than phi se. When the phi sh is less than phi se, at this condition, what happens? Actually, the flux is equals to the minimum value minus maximum value. Hence, this is the negative. When the flux is negative and the armature currents also negative, then if both the negative minus of minus plus, when this is plus, nothing but actually the prime motor torque, where sir? Actually the prime motor torque in this direction. Now in this condition, this is in same direction. There is no change in the same direction of electromagnetic torque. So actually here electromagnetic torque is in this direction, but the speed in this direction. Can you tell me? Can you tell me what happened here? When this is like this is a motor. In motor, the speed should be same direction of electromagnetic torque. I say you. In motor, the rotor rotation should be same of the electromagnetic torque. So speed in this direction. Now the speed direction is opposite. What happens sir here? Speed direction is opposite. When the speed direction is opposite, see here, when the speed direction is opposite, here the torque is in same direction. That's why our speed also in the same direction of electromagnetic torque. Remember this. Now, is the opposite direction okay? Reduce the speed or increase the speed? Comparatively, the flux is reduced. When the flux is reduced, speed increase is nothing. Yes or no? So same, but here the direction of rotor rotation is in opposite direction to the actual direction. This is simply for a long shunt cumulative compound generator. Are you clear? Okay. If you're not clear, let's listen the another question. You have to get total clarity. Okay. So let's go for next question. What is that next question here? The 4C, a short shunt differential compound. Short shunt differential compound DC generator delivering rated power to bus bar. If suddenly prime mover disconnected, then what happens? And here, if they didn't mention anything, or if they are not mentioned here, we have to consider phi sh is greater than phi se. We should remember this point. Okay, so let's see what happened to this condition. Listen carefully, because this is the last question on this. Then after, you have to do every question whatever they given in your examination. Let's see. This is the differential compound. Nothing but phi is equals to phi sh minus phi se. This is fixed. Next, this is a short shunt. That's why, see how it is. This is the short shunt differential compound short shunt generator. That's why this is my EG and this is my RA. Of course, this is my RSE, which flows the current here is ISE. Here my armature current IA. Here my shunt current ISH. And here the line current IL. This is the bus bar. Actually, we are giving a prime mover input in clockwise direction. So the rotor rotates in this direction only. But this is a generator. In every generator, motor action will take place. Due to motor action, electromagnetic torque will develop. that electromagnetic torque is in which direction? Opposite direction to the prime mover torque. This is simply what is my differential compound short shunt generator delivering rated power to the bus bar. But suddenly what happened here? Suddenly my prime mover is disconnected. When the prime mover disconnected, see here, when the prime mover disconnected, then what happens, sir? Machine draws current from the, can you tell me, current from the bus bar. If the machine draws current from the bus bar, nothing but generator acts as a motor. Nothing but a short shunt generator converted as a short shunt motor. Right? This is differential compound generator converted as what? Differential compound or cumulative compound? Let's see. What happened here? When the prime mover disconnected, this is the IL direction, this is the ISC direction, and this is the IA direction. Nothing but here ISE and IA direction reversed. But ISH same direction. There is no change in direction for ISH. So ISC direction reversed, nothing but phi SC direction reversed. So negative, we have to take negative phi SE. ISH direction same, nothing but we have to take phi SH as a positive. So what is phi here? Phi is equals to ISH minus of phi SE. What is phi SE? Minus phi SE. So minus of minus plus. So the answer is phi SH plus phi SE. Here the flux is phi SH plus phi SE. Nothing but differential compound generator converted as a cumulative compound motor. I said you, differential converted as a cumulative, cumulative converted as a differential. This is simply what is the question they asked up to now. Now, is the rotates in same direction or opposite direction? If the rotates in same direction or opposite direction, let's see. Let's see what about torque. The electromagnetic torque directly proportional to phi Ia. Here the flux is positive only, and here also the flux is positive only. Hence completely the flux is positive. And what about armature current? Armature current is reversed, that's why armature current is negative. When the armature current is negative, the electromagnetic torque also reversed. Actually is there my electromagnetic torque. Now the electromagnetic torque is in this direction. Are you okay? When this is in this direction, now this is a motor. In the motor, is it correct or not? Electromagnetic torque and the rotor rotation same direction or opposite direction? This is a motor, right? In the motor, those should be in same direction. When this is in same direction, the rotor also rotates in the same direction of electromagnetic torque. Hence, direction of rotor same. Direction of rotor is same. This is the case. So, the short shunt differential compound generator converted as a short shunt cumulative compound motor which rotates in the same direction with increased speed or reduced speed. Very simple. See here phi SH minus phi SE, here phi SH plus phi SE. When this is there, the flux is increased. When the flux increased, what happens, sir? Tell me. When the flux increased, inversely proportional to flux. If a flux increases, speed reduced. Hence, reduced speed. This is the concept of question. This is very important. Like these questions they will ask you in your competitive examination. Are you okay? Like these questions are important. So here I just explained that what is the processor. Then after, like this many questions we may make. Every question you have to do. Just understand the concept. Once again, see a short shunt differential compound DC generator delivering rated power to the bus bar. This is my short shunt generator actually delivering power. But when the prime mover disconnected, this is act as a motor. Generator act as a motor. Short shunt only, but differential compound converted as a cumulative compound. If it is cumulative compound, it will convert it as a differential compound. Then after, take the torque, about torque. Let's check it the torque. In motor, whatever this is motor, in motor, the electromagnetic torque and the rotor rotation should be in same direction. This is very important. If you understood this, then you can make it easily. So like that, they will ask you questions on this type of questions when the prime mover input disconnected. Okay, let's do the same questions for remaining all questions. What we are solving, you have to do the same solutions. You have to analyze what is going on. So first concept up to now, what is that? What is the direction of motor and generator? Second concept is that supply tunnels reversed. Third concept is that prime mover and field winding and residual magnetism like that reversed. And next concept is that, fourth concept is that, what is prime mover disconnected? When the prime mover is disconnected, generator act as a motor. Based on that, how they will ask you questions. Is it clear? Right?